Hey, fifth grade. Our screencast today is on multiplying whole numbers by decimals. So we're going to start off with just decimals that go through the tenths place. So just one digit after the decimal. Our objective is I can multiply decimals with tenths by multi-digit whole numbers using place value understanding. And we might use some partial products. So before we dive into that skill, I want to do a little warm up, a little review on decomposing decimals or taking them apart, because that will help us later on when we're decomposing decimals with our new skill practice. So I have the same decimal. I wrote it 3 times in 3 different webs, right? 7 and 463 thousandths, and that's in each of my webs. And you can see that I want to break them apart into different place value chunks. So in this web, I want to break 7 and 463 thousandths into ones and thousandths. So I know, okay, this one's easy. That's 7 ones and it's 463 thousandths. If I wanted to break it up into tenths and thousandths, okay, well, I know I would have 7 whole pieces, and that would really be 70 of those tens rods plus 4 more, so that's 74 tenths, and that would mean I'm left with my 63 thousandths. And if I wanted to break this decimal up into hundredths and thousandths, I would have 764 of those little hundredth squares, and I would have only three left of my thousandths. These decomposing webs are actually a really great little mini strategy that you can use when you're thinking of like expanded form, or you have to break apart the decimals, like when we're doing the area model strategies down here. So that's just another little tool that you can put in your toolbox when we're working with decimals, since we will have to decompose them down here. Here's our new skill, multiplying the whole numbers by decimals. We're going to do 3 steps, okay? So the first step is we estimate. The second step is we'll use the area model, and the third step is we'll use the standard algorithm. So you can see I kind of set up each of these steps here. Our first problem is 43, so this is our whole number, 43 times 2 and 4 tenths, 2.4. So when we're estimating, let's round, and let's round our decimal even to a whole number so that they're really easy to work with. So 43, that's close to 40. And 2.4, or 2 and 4 tenths, that's close to 2. It's closer to 2 than it is to 3, so I chose 2. Now, 40 times 2, you might be able to do that mental math in your head, but if you're not sure, you can do 4 times 2 is 8. And how many zeros do you see? Just 1. So 80 is our estimate. So we did step 1, check. Step 2 is to use our area model. So for our area model, we are going to decompose, that's up here, decompose, break apart our numbers, just like we do when we're using whole numbers in the matrix. So 43 is going to become 40 plus 3. Okay, and then 2 and 4 tenths, I'm going to use all tenths for this. So I'm going to have 20 tenths plus 4 tenths. My whole number, my whole decimal just got turned into tenths, because it's really like renaming 2 whole numbers into 20 tenths, and then we have 4 extra tenths. So our decomposing map would be like 2.4, and then we have 20 tenths, and then we have the 4 tenths, right? This is our whole number that we're breaking up, and then those are our extra tenths. Okay, so anyway, we are going to start multiplying. 3 times 2 is 6 and 1 0. 2 times 4 is 8 and 2 zeros. And then we have 3 times 4 is 12. 4 times 4 is 16 plus 1 0. Okay. You know the next step is to add everything up inside of this. So this would be 960, and this row would be 72. And if we add that up, we'll get 1,000 1,032. That is not our final answer because remember we changed this into only tenths. So 1,032 tenths is our answer. And I have to figure out how to write that back as a whole number. So let's go ahead and use our standard algorithm, see what answer we get, and then we'll figure out how to change this back into a whole number. For the standard algorithm, we are going to pretend like the decimal is not there and we'll add it back in at the end. 3 times 4 is 12. Write the 2, carry the 1. 4 times 4 is 16. Plus 1 is 17. Now I'm in the tens place. So I put a 0 as my placeholder, and I have 2 times 3 is 6. 2 times 4 is 8. And I'm adding. 2 plus 0 is 2. 7 plus 1. 7 plus 6. We almost had a pitfall there. Is 13. Carry the 1. And 8 plus 1 is 9. Plus another 1 is 10. So we get 1,032, just like we did here. And we have one place to swoop. Okay, so when we put our decimal back in, we get 103 and 2 tenths. 103 and 2 tenths will be our final answer. If you're going from tenths back to a whole number, you can just divide this answer by 10 or move the decimal in one place. So our final product for 43 times 2.4 is 103.2, or 103 and 2 tenths. We can check to see if that was close to our estimate. Yeah, it's pretty close to 80, so that's how we know that we were right. And let's go ahead and do one more problem so that we can become a little bit more fluent. And we're starting off with estimating. So 3.5, or 3 and 5 tenths, is closer to 4 than it is to 3, so I rounded that to 4. And 42 is closer to 40 than it is to 50. So I can do 4 times 4, that's 16. And then there's 1 0. Our estimate is 160, so that's where our answer should be. And I'm going to take this first number and change it all into tenths again. So if I had 3 whole numbers and 5 tenths, I could break my whole numbers up. This whole block is worth 10 of those tens rods, right? 3, 4, 5, 6, 7, 8, 9, 10. And I can trade that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can trade out my third one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 20, 30. There are 30 tens rods, and then 1, 2, 3, 4, 5 more. So this is going to be 30 plus 5 tenths. That's how I decomposed my 3.5. And then my 42 will be 2 plus 40. And I would use this example to help you if you're trying to use the area model while you're decomposing your decimals so that you're doing it the right way. We're going to start multiplying. We get 12, 1, 2, 6. 5 times 4 is 20, and then 1 more 0. Okay, so you know that we would have to add everything up. So we have 70 tenths here, and then we have 1,400 tenths here in this row. And then when we add that, okay, so 1,470 tenths. I know from the last problem that we would just have to move the decimal in one place to get back to our whole numbers. So 147 should be our answer. Ooh, that's close to our estimate. So let's see if we get that with our standard algorithm. For our standard algorithm, we're going to start in the ones place with this 2. So 2 times 5 is 10. Write the 0, carry the 1. And 2 times 3 is 6, plus 1 is 7. We're done with the 2, cross out our 1 that we carried, and I put a 0 in the ones place as a placeholder because now we're working with the 4 in the 10 spot. 4 times 5 is 20, write the 0, carry the 2. 4 times 3 is 12, plus 2 is 14. When we add, we get 1,470. If I know I'm working with 35 tenths, like we decomposed up here, I can put my decimal back in one place value spot. If I didn't write tenths here, and I wrote the problem how it appears, 3.5 5 times 42, I would know to just swoop the decimal 1 in. So 147.0 would be 147 whole numbers. Another really cool thing about using the area model and the standard algorithm at the same time is that when you line these up, so 60 plus 10 is 70, you see that same pattern here in your standard algorithm. Here's your 70 that you got up here. Here is your 1400. You see that here, 1200 plus 200. So these kind of reflect the same work, but this one you're doing it in a more visual kinesthetic way, and this one you're doing it in a more like step-by-step procedural mathematical way. And we can see that in this problem too. Here we had 72. Here's our 72 is when we added 60 plus 12 up here, and we get 800 plus 160 is 960. We saw that work here when we carried. So it's kind of cool to see the similarities between these two strategies, because it's all about just a preference of how your brain works when you're learning. All right, we're gonna practice more of these together right now in our groups and independently. Before you're allowed to start that though, I want you to set up 2 spaces in your notebook. I kind of made mine into columns. So one says standard algorithm, one says area model. And I want you to write out how to use these strategies so that someone else could look at your steps and know how to do this up here. This will be a really good summarizing strategy for you to use so that you can reflect on what we just practiced up here, so that later today, tomorrow, a week from now, a month from now, you can look back at your notes and say, oh, these are the steps for how to use the area model. Oh, these are the steps for how to use the standard algorithm when we have decimals. And it'll be more meaningful if it's in your words, okay? So you can do step by step. You can do number 1, that didn't write very well. Number 1, this is the first step. Number 2, this is the second step. Number 3, this is the third step. You can have as many steps as you need so that you can get through the entire problem. Or you can just do like stars or bullet points for tips on how to solve those. Thanks so much.